Record on. What are we doing today?
We're doing grouping now, factor by grouping.
Give me some problems.
All right, n cubed plus 5m squared plus 4m plus 20.
Okay. Do you know how to do this?
I think a little. I mean, not really. We just, like, we learned it the last 10 minutes of class. So.
Let me give you a clue, first of all. This is a cubic, which are notoriously difficult to factor. I mean, really hard, unless they fit into a category that can be grouped. And then that's pretty easy. This is a very small percentage of cubics that can be grouped. But what you need is the coefficient ratios to be the same. Between this term here, we have 1/5. You see that?
Mm-hmm.
And between this term here, we have 4/20, which is also 1/5. As long as those ratios are exactly the same, then you can group it. Has to be that way. If this was 19 instead of 20, no chance.
Mm-hmm.
Okay? So that's the first rule for grouping, is that the ratio of the first two coefficients has to be the same as the ratio of the last two coefficients. Now, how do you group? Well, you group the first two terms together and you group the last two terms together. So basically, I'm going to do this. Put parentheses around them. Put parentheses around that. Now, I haven't changed anything. And that's very important when you're doing a lot of math, is when you go from one row to another, you do not want to change anything. If I'd have written plus 19, I would have changed it. It wouldn't have been the same as the first row. I need it to be the same as the first row. Okay. Mm-hmm. Now I want you to take each set of parentheses and take the greatest common factor out. What's the greatest common factor in the first set of parentheses?
N squared.
What's left over?
N plus 5n. Or n plus 5, sorry.
Okay. Do the same thing in the second.
It would be 4, and then it would be 4, and then it would be n plus 5.
Aha. Now, this is a step, the next step is a step you've probably never taken before. But it falls in the category of greatest common factor. If I want to factor something out of that expression, what is the greatest common factor?
1.
It's not easy to see because you're used to always having the greatest common factor be a monomial term. In this case, this is the greatest common factor. It's the binomial term. I can factor out an m plus 5. What's left over?
Is n squared plus 4.
There you go. Now, that's as far as I can go down, and so that's the answer. But you can imagine that if this was n squared minus 4, then I could take it down to n minus 2 times n plus 2, and I would have 3 linear factors. I was erasing, and I may have changed the problem. Was that plus 4n plus 20?
Yeah.
Okay. Then that's the answer. In other words, when you reach a level where you can't go down any further, that's it. As I said, if this would have come out to, say, be n minus 4, now I've got n plus 5 times n minus 2 times n plus 2. 3 linear factors. All right, what else you got?
This looks hard. 21n cubed minus 84n squared plus 15n minus 60. And for the n cubed, it was 21n cubed.
Okay. So, if we're going to group this, does this qualify? What has to be true? What has to be true?
They have to have the same
ratios. So
yeah, ratio.
21 over negative 84, is that the same as 15 over negative 60?
Yeah.
Got to be exactly the same. Yes, that's negative 1/4. That's negative 1/4. Okay? So, it lends itself to grouping. In other words, we can solve this by grouping. Tell me what the next line should be with parentheses.
So parentheses 21n cubed minus 84n squared, and then in parentheses, and then starting parentheses 15n minus 60.
And then a plus sign.
Plus sign, yeah.
Because sometimes that's negative, and that makes it much harder. But in this case, they're still giving us a plus sign, which makes it easy. Next line.
It would be
Greatest common factor out of that first set of parentheses.
okay. So it would be n or 7n squared.
About 21n squared.
20. Oh yeah, that works. Yeah.
Does, doesn't it? And that's what,
yeah.
when I say greatest common factor, that's what it means, is the greatest.
Yeah, and then that would be n minus 3. 4.
Okay? And on the other side?
15 would be the greatest common. 15, yeah, 15. And then you'd be left with n minus 4.
Okay. Now, when you're doing these problems, if this is not the same as that, you've made a mistake. That's all there is to it. It's always going to be the same. If one of them ends up being n minus 4 and the other one ends up being n plus 4, you've made a mistake. Go back, try it again. In other words, if these weren't exactly the same, we wouldn't be able to go anywhere. They have to be exactly the same for us to take out the greatest common factor again. So what's the greatest common factor now?
N minus 4.
And in parentheses, times what?
21n squared plus 15.
And I can actually take out another factor. What else can I do? What can I do with that? I can't do much, but I can do something. So I still have my n minus 4. Well, what can I take out? There's a greatest common factor that I can take out of that. What number is the greatest number that divides into 21 and also 15? 3.
Yeah, 3.
leaving 7n squared plus 5. And now I can't go down any further. In fact, I'm going to put the 3 there, and as opposed to being in between those others, and that is your final answer.
Mm-hmm.
So you always have to take it down as far as you can go. That's part of the requirements. Now, I'm going to change this problem just a little bit to make it next level difficult. Just to point out something, to avoid you making the mistake that everybody makes when it's the following situation.
Okay.
I'm going to change that to a negative sign and that to a positive sign. Now, does it still meet the requirements for grouping?
Yes.
Okay. So what's the next line with parentheses?
Well, it would be 21n cubed minus 84n squared, and then minus 15, or parentheses 15n plus 60.
Aha, that's the mistake everybody makes. Notice that if I wrote it like that, is that the same as the first line?
That would, wait,
No.
no, wait, yeah, no.
Because it would be minus 60, wouldn't it?
Yeah. Yeah.
So in order to make it the same as the first line, that has to be minus.
Mm-hmm.
And that's a very, very important part. So whenever your first two terms and your last two terms are separated by a minus, always remember that when you add the second set of parentheses, you have to do something. You have to change the sign on the constant in order to make it the same. And now, when I factor out the greatest common factor, still 21n squared over here, leaving n minus 4. And over here, it's still 15, leaving n minus 4.
Mm-hmm.
Now I'm going to factor out the n minus 4, leaving 21n squared minus 15. I'll factor out the 3, leaving 3 times n minus 4 times 7n squared minus 5. So that would be my final answer.
Mm-hmm.
But the key distinction is that negative sign right there. When you see that negative sign separating the first two terms and the last two terms, be very careful when you write the second line that it matches the first line.
Okay.
I mean, I'm telling you, 95% of students make the same mistake you made, where they make that a plus 60. And it's not a plus 60. When I add parentheses to those last two terms, I've got to turn that into a negative, because this negative sign gets distributed to both terms. And that's why you have to do that. All right, what else you got?
I mean, I only have grouping problems right now.
That's okay. Let's do another few of those. Yeah. Let's make sure. That's the way to make sure you know how to do them, is for me to explain how to do them and then for you to do some.
All right, 28x cubed plus 16x squared minus 21x minus 12.
Notice this minus sign right there. This is the harder kind. This is the one that it's easy to make a mistake on. So tell me what the second line with parentheses is. Notice that when I add parentheses to the first two terms, you never have to change anything. Mm-hmm. Parentheses on the first two terms do not affect anything. Now, what goes there.
All right, so it would be 21x plus 12.
Now, go through each set of parentheses and take out the greatest common factor.
Okay. Well, first one would be 8. So it would be,
It doesn't go into 28.
or it would be 2.
How about something in between those?
4.
Huh? Notice that 4 goes into 28 and 4 goes into 16.
Okay.
So there's
So,
the number. What's the variable? It goes with it.
x squared, and then it'd be 7x plus 4.
Now, one of the keys and clues here is that you know what's going to be left behind has to be 7x plus 4.
Mm-hmm.
So what's the greatest common factor?
It would be 3.
Uh-huh.
And then 7x plus 4.
Yeah. In other words, they kind of give you a clue, so you don't have to go through the greatest common factor process again. You know that what's left has to be 7x plus 4. Because the next step is what?
Find the greatest common factor from that, which is 7x plus 4.
In parentheses,
Mm-hmm.
times what?
It would be 4x squared minus 3.
Yeah. And that's going to be your final answer. Occasionally, this will be a perfect square number like 1.
Mm-hmm.
And I could take it down further. In other words, that would equal 7x plus 4. And using difference of perfect squares, that would be 2x minus 1 times 2x plus 1.
Mm-hmm.
So again, it's nice if you can take it down to 3 linear factors. Because this is a 3 and not a 1, I don't have to do that. I can leave that as the answer. Although, in all honesty, you don't need it to be difference of perfect squares. That is actually the answer. But they don't teach you that in the level of math that you're in. In other words, when you have the difference of two numbers, you can always factor it as the square root of the first minus the square root of the second times the square root of the first plus the square root of the second. So it doesn't actually have to be perfect squares, but they teach it that way. So I don't want to get ahead of the game for you. All right, what else? We got 10 minutes. Do we have anything harder? That was harder. That was that extra level where you had to be very careful about the sign because subtraction was going on.
I think here's one.
Okay.
12p cubed minus 21p squared plus, plus 28p minus 49.
Okay, so this is going to be relatively easy because we're looking at a plus sign. So I could essentially put parentheses around those two without changing anything.
Mm-hmm.
Now, does it lend itself to grouping?
Yes.
Let's check. Is 12 over minus 21, is that equal to 28 over minus 49? Now I can divide this by 3, so that becomes 4 over minus 7. I can divide this by 7, that becomes 4 over minus 7. So yes, we can group it. We can solve it by grouping.
Mm-hmm.
It's the next line. Now notice, I went ahead and added the parentheses. I don't have to rewrite that line. Because when you are adding, then adding parentheses to the last two terms doesn't change anything. I don't have to go in and change the sign on that 49. If I am subtracting, I do.
Mm-hmm.
Okay, so what's the next line?
It would be 12p squared,
Hold on.
parentheses,
12 divided into 21?
or no,
Got to find the greatest common factor in the number part first, which is 12 and 21. What's the greatest common factor? The way to figure this out, Blake, easily is to start with your low numbers. Does 2 divide into 12 and 21? No odd number is divisible by 2. So the answer is no.
yes and no.
Does 3 divide into 12 and 21?
Yes.
Yeah, okay, so there's a start. So let's take out a 3. We'll find out soon enough whether that was the biggest one. How many, and you've already figured out that we can take out a 3p squared. What's left over?
It would be 4p minus 7.
Okay. Now, knowing that this is going to be 4p minus 7, what's the greatest common factor?
7.
See how that makes it a little easier?
Mm-hmm.
And then what's the last row?
It would be parentheses 4p minus 7, and then another parentheses 3p squared plus 7.
Now, that's going to be your final answer. There's nothing else I can factor out of either of those expressions. And one thing to memorize or to note is that if that's addition, I can never factor it further unless I could take a number out. If it's subtraction, then often it will fit difference of perfect squares and I can factor it further. But that's what makes the difference, is whether you're looking at a plus sign or a minus sign there. Okay? You got any more?
No, not really.
Let me make one up. Work me through your entire thought process in factoring this. I will try to say as little as possible.
Alright, so it would be 3x cubed, and then it would be minus 9x squared.
Give me parentheses, addition signs, subtraction signs. What's the first step that you forgot to do? Check the ratio of those coefficients, because this might not lend itself to grouping. To be honest with you, not very many cubics lend themselves to grouping. Maybe 1%. It's just the first thing they teach you, because the real method of factoring cubics is unbelievably hard, much harder than quadratics. A typical cubic problem is like a 20-minute problem. You only get one of them on a test because they take so long. And I'm not talking about these. These lend themselves to grouping. But what is required for this to lend itself to grouping?
Same ratio.
What's the ratio on the first two?
1/3.
Is it positive or negative?
Negative.
What's the ratio on the second term?
Negative 1/3.
Well, it's -4 over -12. That's positive.
Or, yeah, positive 1/3.
That means it does not lend itself to grouping. I was trying to trick you. So, let's turn that into a plus, and now it will lend itself to grouping, because we now have 3 over -9. Is that equal to -4 over positive 12? And yes, they're both equal to -1/3. So it's got to be exact. Same sign even. Now, what's the next line? With parentheses.
It would be parentheses, 3x cubed minus 9x squared. And then it would be parentheses minus...
There's a sign in there.
Minus, sorry.
It's always the same. If that middle term is a minus, then we're going to use a minus here.
And then it would be minus 4x.
No?
4x plus 12? Sure. 12.
Is this the same as this?
Yeah.
Yeah. In other words, when I ask that question, what I mean is if I were to remove the parentheses, then this becomes, parentheses never affect the first two terms. This becomes minus 4x, but then this has to be applied to that, so that would become plus 12. That's what I started with. That's what you want to make sure, is that you end up exactly with what you started with. If it's different in any way, shape, or form, then you've done it wrong. Okay?
Mm-hmm.
Next step.
Alright, greatest common factor would be 3x squared, and then it would be x minus 3, and then it would be minus parentheses, not parentheses, it would be 4 as the greatest common factor, then it would be x minus 3.
Yeah. Now,
and then
before you go forward, if you've made a mistake in your signs in going from step 1 to step 2, it will show up in step 3. In other words, what you'll end up with is a plus sign there. So if you end up with that term not being the same as that term, you know you've made a mistake. And the only mistake that everybody makes is the sign on that term. So make sure when you get to step 3, you've got two binomial terms that are the same. Because there's no way they're giving you a problem if these were different. They're just not giving you that problem. Okay? In other words, if they give you a problem that says solve by grouping, then you can bet 100% that you're going to be able to solve it by grouping. And yet, if that came out x minus 3 and that came out x plus 3, I'd be stuck. I could not go anywhere if it really came out to be that. But when you're doing it, if it comes out to be that, what it says is that you've made a mistake. Go back and figure out where you made your mistake and redo it. And the most common mistake is when you go from there to there and getting the sign on the 12 wrong. So what's the final line?
It would be x, or parentheses, x minus 3, and then 3, or parentheses, 3x squared minus 4.
Okay. Well, again, we can't take that down any further. Had I been a little smarter and constructed the problem like that, so it came out to be that, now let's assume that that was the answer. What can I reduce that to? Can I factor that quadratic that's there? In other words, this quadratic right there. Can I factor that?
Is that a 4? 4x?
You could definitely take a 4 out.
Yeah.
I can do something better than that. That is the difference of perfect squares. Right? Isn't 4x squared a perfect square?
4x squared?
Yeah, what's the square root of 4x squared?
It would be 2x.
Okay. And isn't 4 a perfect square? What's the square root of 4?
2.
And it's always a minus for the first one. So it's 2x minus 2 times what? The second term is always exactly the same.
2x plus 2.
Yeah, it's called the conjugate. Now, is that in final form?
Yeah.
Actually take a 2 out of both of those terms. So the final term, I'm going to write it up here and then I'll let you go, is x minus 3. I'm going to take a 2 out of that term. I'm going to take a 2 out of that term. That's going to equal 4. And what's left is x minus 1 times x plus 1. And that is actually completely factored. Notice I have 3 linear terms and I have a number. All right. Blake, that should have been helpful. I think you know how to do grouping.
It was.
I will talk to you next time.
Alright, you too. Have a good day.
Bye-bye.